So hello brother. So regarding the solution of this particular problem, so we are asked to determine the steady state response of the system to the input signal. So we know this is the output signal and this is the input signal. So we want to get the steady state response of the system. So the first thing we'll need to do is to get the frequency response. And the frequency response can be obtained from this formula, which is h of omega, y over omega over x of omega. So we need to look for y of omega. This eventually is going to be the formula for the steady state of the system. We apply this to each term of the input signal. You get it? So now the first we want to do now is to get y of omega. So we know y of n is given here to be half x of n. That's x of n minus x of n minus 2. So that's what is given here. Now, so to get this one, y of omega is going to be half. So it's going to be x of omega minus, now this one is having a delay of 2. So, and if we have to represent that, it's going to be e raised to power minus j omega 2 x of omega. So this one will be represented. And if we now if we now kind of find the response of this system, now if we bring out, this is y of omega, so x of omega, bring it out, is going to be half 1 minus e raised to power minus j omega 2 x of omega, right? Factorize the x of omega out of the system. So this is now going to be y of omega all over x of omega, and that will be half 1 minus e raised to power minus j omega 2, right? So after we have found this, so the next thing we want to do is to now look for, now if you look at the input, so we know this is equal to h of omega, right? This is equal to h of omega. Now, this h of omega that we'll obtain now is to enable us to find this particular response at different angles, at different angles of the system. The value of x of n, the value of omega here at this point is equals to 0. The value of omega here is pi over 2, and the value of omega here is pi. So at these three different frequencies, we are going to determine, the frequency response at those 3 points. So we find h of omega. We find the h of omega at 0, at pi all over 2, and at pi. So at this different 3 different frequencies. So what we now do at this point is to get h of 0. H of 0 is going to give us, we put 0 inside this system. So that's going to be 1 all over 2, 1 minus e raised to power minus j omega. This is going to be 0, right? So, and you know what that means. So if e raised to power 0 is 0, right? And e raised to power 0 is 1, rather. E raised to power 0 is 1, and that's going to be, so that's going to be 1 minus 1, and that is going to be 0, right? So everything here is going to be equal to 0. Now we also need to determine h at pi all over 2. So it's going to be half 1 minus e raised to power minus j. Sorry, this is supposed to be 2. So it's going to be 2. And we put pi all over 2 there. So when you put this one here, we are going to get e raised to power minus j pi, right? So, and having got this one, so you know that by the time you compute this and this, e raised to power j pi, is going to give us cos pi is going to give us this is going to be equal to 1 minus cos pi, then plus j sine pi, right? And you know that cos pi is going to give you what? is going to be 1. Cos pi is minus 1. So everything will be plus 1. And sin pi, of course, is equals to 0. So this is going to be 1 eventually at the end of the day. Now, h of pi, which is the third one. So we also insert it into this system. So minus j 2 pi, right? So if we put it here, we know that this is going to be 1 minus cos pi plus j sin pi, right? And 2 pi is going to be 2 pi sine 2 pi, right? So by the time we put it inside the system as well, we know what our cos pi will give us. Cos 2 pi rather. Cos 2 pi is going to give us 1. And sine 2 pi, of course, is equals to 0. So by the time we put 1 minus 1, it's going to be equal to what? It's going to be 0. And eventually everything becomes 0, right? So now the input to the system, that's x of n. X of n, let's bring it out. X of n is equal to 5 plus 3 cos pi all over 2n plus 60 degree plus 4 sine n pi plus 45 degree. You see, so now that we have this, so the next thing we want to do is now to look for the steady state response of the system. And to get that steady state response, which is y of n, our y of n eventually will be equal to y of n will be equal to 5 multiplied by h of 0, that is h of 0, the one we got earlier, then plus 3 multiplying h of pi all over 2, right? Then cos pi all over 2n plus 60, then plus 4 h of pi, right? H of pi, then sine n pi plus 45. So we should not forget we are supposed to add the angle of this one, angle of h of 90 here. We also need to add the angle of h of pi. So we need to add the angles there inside the, the magnitude and the phase will be added together. So we should not forget this is where this one is going to be, this particular one. So having done this, so we'll now put those values there. 5 h of 0, that we got earlier. We got our h of 0 to be 0. So 5 multiplied by 0 will be 0. Then h of 90, we got that one to be 1. So 3 multiplied by 1 cos. So this is going to be pi all over 2n plus 60 degree. Then plus, what is the angle? So the angle of that h of 90 is, of course, the angle is 0 because it does not have any angle. So it's 0 at this point. Then plus 4 h of 0, h of pi rather, is equals to 0 at this point. So sine n pi plus 45 plus the 0, it does not have angle. Do you get it? So once we have obtained those ones, so our y of n at this point is now going to be, so our y of n is going to be 5 times 0, we know it is 0. So we are only left with this one, which is 3 cos pi all over 2n plus 60 degree, right? So where n, of course, is beginning from minus infinity to infinity. So this is the eventual result. This is the steady state response of the system. So if you look at the question again from the beginning, what they want us to get is to get the steady state response of the system. And that is what we have obtained using this formula. So we use this formula, and this formula is what we have used at this point. So we have the magnitude of the cosine, whether we have a sine or cosine, the magnitude of that cosine multiplied by the impulse response. So and we need to just determine the impulse response. Then we need to insert it into the equation to be able to get the steady state response of the system, which is what we got at this point. So I believe this is clear. Okay.